Hello everyone. Today we are going to analyze this frame using Kani's method. Before analyzing, let us see the frame one time. In this frame, we have the columns AB and CD and the beam BC. In the columns, there are no loads. In the beam BC, we have a uniformly distributed load 4 kN per meter and it is acting for the full span. In the point B, we have a nodal point load 12 kN. It is acting towards the right side. For the columns, the moment of inertia is 4I and for the beam it is 1.5I. Height of the columns are 4 meter. Length of the beam is 6 meter. This is a sway type frame. Because of this load, there will be sway. In the Kani's method, we have to find the rotation factor. To find the rotation factor, we have to calculate the stiffness. Let us see the formulas to find the stiffness. If the fare end is fixed, the formula is 4EI upon L. If the fare end is hinged or with roller support, the formula is 3EI upon L. If the fare end is continuous, the formula is 4EI upon L. In this frame, both of the ends are fixed. The points B and C are continuous. So, for the stiffness of BA, BC, CB and CD, we have to use the same formula 4EI upon L. First, let us find the stiffness for BA. Length of BA is 4. Let us apply that. The moment of inertia is 4I. So, in the formula, instead of I, we have to apply 4I. After calculation, for the stiffness of BA, we are getting 4EI. Now let us find the stiffness for BC. Length of BC is 6. Let us apply that. The moment of inertia for BC is 1.5I. After calculation, for the stiffness of BC, we are getting EI. We know that the stiffness of BC and CB will be same. Now let us find the stiffness for CD. Length of CD is 4. The moment of inertia for CD is 4I. After the calculation, we are getting 4EI. Now let us find sigma k. In the joint B, we have to add these two values. After adding, we are getting 5EI. In the joint C, we have to add these two values. After adding, we are getting 5EI. Now let us find the rotation factor. The formula is -1 upon 2 into k upon sigma k. We have calculated k and sigma k values. Using this formula, we can find the rotation factors. We know that this is a sway type frame. For the columns BA and CD, we have to find the displacement factor. In this frame, both of the columns are having the same height, 4, and in both of the ends, we have fixed supports. In this case, the formula for the displacement factor is -3 upon 2 into k upon sigma k. For the column BA and CD, we have already calculated the stiffness values. Now let us find sigma k. For that, we have to add these two values. After adding, we are getting 8EI. Then, using this formula, we can find the displacement factors. Now, let us find the story moment. The formula is SR upon 3. SR is the story shear. To get the story shear, we have to add the horizontal reactions in the points B and C. In the column CD, there is no load, so there is no horizontal reaction in the point C. Now let us take the column AB. In the point B, we have a nodal point load 12 kN. it is acting towards the right side. So the reaction should be acting towards the left side. If the reaction acting towards the left side, that will be positive. So our storage shear is 12 kN. HR is the reference height. We have two columns, column AB and column CD. We have to select any one of the column as the reference column. Both of the columns are having the same height, 4 meter, and both of the ends are fixed. In this case, for the reference height, we can simply enter the height 4. After the calculation, for the story moment, we are getting 16 kilonewton meter. In the Kani's method, in the joints, we have to make rectangles like these. Now let us enter the fixed end moments. M of AB here, M of BA here, M of BC here, M of CB here, M of CD here, and M of DC here. In the joints, we have to add the fixed end moments. In the joint B, when we add these two values, we will get minus 12. In the joint C, when we add these two values, we will get 12. Now let us enter the rotation factors. For BA, it is minus 0.4. For BC, it is minus 0.1. For CB, it is minus 0.1. And for CD, it is minus 0.4. Now let us enter the displacement factors. For the column AB, it is minus 0.75, and for the column CD also, it is minus 0.75. In the Kani's method, in the joints, we have to find the rotation contributions. In the joint B, we have to find M dash BA and M dash BC. In the joint C, we have to find M dash CB and M dash CD. We know that this is a suede type frame. So additionally, we have to find the displacement contributions. For the column AB, we have to find M double dash AB, and for the column CD, we have to find M double dash DC. To find the rotation contributions, let us use a formula. Summation of rotation or displacement contributions at far end plus summation of fixed end moments into rotation factor. Now in the joint B, let us find the rotation contributions M dash BA and M dash BC. For the joint B, the fair ends are the point A and the point C. In the point A, initially M double dash AB will be 0. In the point C also, initially M dash CB will be 0. So for the summation of rotation or displacement contributions at fair end, we have 0 plus 0. The summation of fixed end moments is minus 12. The rotation factor for BA is minus 0.4 and for BC is minus 0.1. After the calculation for M-BA we are getting 4.8 and for M-BC we are getting 1.2. Let us apply M-BA and M-BC. Now in the joint C, let us find the rotation contributions. For the joint C, the fair ends are the point B and the point D. In the point B, we have the rotation contribution 1.2. In the point D, initially M double dash DC will be 0. So for the summation of rotation or displacement contributions at fair end, we have 1.2 plus 0. The summation of fixed end moments is 12. The rotation factor for CB is minus 0.1 and for CD is minus 0.4. After the calculation for M-CB we are getting minus 1.32 and for M-CD we are getting minus 5.28. Let us enter them. Now let us find the displacement contributions M double dash AB and M double dash DC. The formula is story movement plus summation of rotation contributions at the top and bottom of the columns into displacement factor. In this analysis, for both of the columns, we have the same displacement factor minus 0.75. So the values of m double dash AB and m double dash DC will be same. We have already calculated the story movement 16. Let us take the column AB. In the top of the column, we have the rotation contribution 4.8. In the bottom of the column, the rotation contribution will be 0 because in the fixed ends there will be no rotation contribution. Let us take the column CD. In the top, we have the rotation contribution minus 5.28. We know that in the bottom, the rotation contribution will be 0 because it is a fixed end. So for the summation of rotation contributions at the top and bottom of the columns, we have 0 plus 4.8 minus 5.28 plus 0. The displacement factor for both of the columns is minus 0.75. Finally, for m double dash AB and m double dash DC, we are getting minus 11.64. Let us apply them. We have finished the first iteration. Let us start the second iteration. Let us find m dash BA and m dash BC. Now in the point A, we have the displacement contribution minus 11.64. In the point C also, we have the rotation contribution minus 1.32. The summation of fixed end movement is minus 12. Then let us apply the rotation factors for BA minus 0.4 and for BC minus 0.1. After the calculation, we are getting m dash BA and m dash BC. Let us enter them. Now let us find m dash CB and m dash CD. In the point B, now we have the latest rotation contribution 2.496. In the point D, we have the displacement contribution minus 11.64. The summation of fixed end movement is 12. The rotation factor for CB is minus 0.1 and for CD is minus 0.4. After the calculation, we are getting m dash CB and m dash CD. Let us enter them. Now let us find the displacement contributions m double dash AB and m double dash DC. Let us apply the story movement 16. Let us take the column AB. We know that on the bottom the rotation contribution will be 0. On the top we have the rotation contribution 9.984. Now let us take the column CD. On the top we have the rotation contribution minus 1.142 and on the bottom it is 0. Then let us apply the displacement factors. After the calculation, we are getting m double dash AB and m double dash DC. Let us enter them. Now we have finished the second iteration. Let us start the third iteration. Let us find m dash BA and m dash BC. In the point A, now we have the latest displacement contribution minus 18.631. In the point C, we have the latest rotation contribution minus 0.286. The summation of the fixed end movements is minus 12. The rotation factor for BA is minus 0.4 and for BC is minus 0.1. After calculation, we are getting m dash BA and m dash BC. Let us enter them. Now let us find m dash CB and m dash CD. In the point B, we have the latest rotation contribution 3.092. In the point D, we have the latest displacement contribution minus 18.631. Then let us apply the summation of fixed end movements The rotation factor for CB is minus 0.1 and for CD is minus 0.4. After the calculation, we are getting m dash CB and m dash CD. Let us enter them. Now let us find m double dash AB and m double dash DC. In the column AB, we have the rotation contributions 0 and 12.367. In CD, we have the rotation contributions 1.416 and 0. We have to add all of them. The story moment is 16. Then let us apply the displacement factors. After the calculation, we are getting m double dash AB and m double dash DC. Let us enter them. We have finished the third iteration. Let us start the fourth iteration. Let us find m dash BA and m dash BC. For that, we have to add these three values and then multiply with the rotation factors. After the calculation, we are getting m dash BA and m dash BC. Let us enter them. Now let us find m dash CB and m dash CD. For that, we have to add these three values and then multiply with the rotation factors. After the calculation, we are getting m dash CB and m dash CD. Let us enter them. Now let us find the displacement contributions. For that, with the story movement, we have to add these two values and then multiply with the displacement factors. After the calculation, we are getting m double dash AB and m double dash DC. Let us enter them. We have finished the fourth iteration. Let us start the fifth iteration. Let us find m dash BA and m dash BC. For that, we have to add these three values and then multiply with the rotation factors. After the calculation, we are getting m dash BA and m dash BC. Let us enter them. Now let us find m dash CB and m dash CD. For that, we have to add these three values and then multiply with the rotation factors. After the calculation, we are getting m dash CB and m dash CD. Let us enter them. Now let us find the displacement contributions. For that, with the story movement, we have to add these two values and then multiply with the displacement factors. After the calculation, we are getting m double dash AB and m double dash DC. Let us enter them. We have finished the fifth iteration. Let us start the sixth iteration. Now let us find m dash BA and m dash BC. For that, we have to add these three values and then multiply with the rotation factors. Finally, we are getting m dash BA and m dash BC. Let us enter them. Now let us find m dash CB and m dash CD. For that, we have to add these three values and then multiply with the rotation factors. When we do that, we are getting m dash CB and m dash CD. Let us enter them. Now let us find the displacement contributions. For that, with the story movement, we have to add these two values and then multiply with the displacement factors. Finally, we are getting m double dash AB and m double dash DC. Let us enter them. We have finished the sixth iteration. We can stop in the fifth or sixth iteration, but I want to do two more iterations. Here I have done the seventh iteration for the rotation contributions. Here for the displacement contributions. Here I have done the eighth iteration for the rotation contributions. And here for the displacement contributions. So I have done 8 iterations, but it is not necessary to go for 8th iteration. You can stop in the 5th or 6th iterations. Now let us find the final movements. The formula is fixed end moment plus 2 into rotation contribution at near end plus rotation contribution at far end plus displacement contribution. Let us make a table. In the table, first let us enter all of the members. Then let us enter the fixed end moments. Then let us enter 2 into near end rotation contributions. We know that in the points A and D, the rotation contributions are 0 because in these points we have fixed supports. So for AB and DC, 2 into 0. For BA, it is 14.834. For BC, it is 3.708. For CB, it is 1.039. For CD, it is 4.156. Using the arrows, we can enter the far end rotation contributions. Now let us enter the displacement contributions. For the columns A, B and C, D, it is minus 26.242. So for AB, BA, CD and DC, we have to enter that. The displacement contribution is only available in the columns. In the beam BC, it will not be available. So for BC and CB, there are no displacement contributions. After adding these four values, we will get the final moments. In the joint B for BA and BC, for the moments we must get the same value, but here we are getting different values. So let us take the average of these two, 3.43 plus 3.54 by 2, we will get 3.48. Similarly, for CB and CD, we can take the average of these two, 17.79 plus 17.93 by 2, we will get 17.86. Here I have drawn the bending moment diagram. Now we are going to end this session. Thank you for watching this video.